I'm Dr. Keisha Bahr. I am reporting live. I'm a reporter now, reporting live from Hawaii, the Hawaii Institute of Marine Biology. And I'm really excited about this partnership with the Texas State Aquarium because we're able to bring coral reefs closer to you, regardless of where you are. And you get to join me on my research expedition to learn more about the mysteries surrounding coral reefs. So welcome to the first ever live event. I promise in the future we'll be way better with technology. You can ask any of my students. I am the worst person with technology. So I really appreciate your patience. So I want to just give you a little bit of insight about what to expect from this live event. First, we're going to talk about the goals of our first research expedition. Why am I here? What am I going to be doing? Why are you here? Why are you joining me? We're going to be talking about some of the experiments that we're going to be doing, and we're going to be learning more about corals and coral reefs. But most importantly, which is the coolest thing about this entire live event, and we appreciate you hanging in there, is I'm going to be answering your questions live. So if you have any questions, go ahead and write them in the comment section, and I will be able to answer those live for you. So just remember to enter your questions at any time, and I will answer those. So I want to remind everyone that this is part of a larger conservation series focused on corals. So if you haven't had a chance to check it out, we're going to drop the link for the first episode, the first series, talking more about this research expedition and giving you some more background and insights about the work that we're doing out here in Hawaii. So let's get started. First of all, let me tell you where I am. I am at the Hawaii Institute of Marine Biology, which is located on Moku'oloi, or also known as Coconut Island, which is a smaller island off of the island of Oahu. So you can imagine, you can see behind me, this is not a green screen. This is beautiful, gorgeous day here in Hawaii. And what's really unique about being here is this is where I got all of my research started. So for the past decade, I've been researching and trying to understand what's going on with the coral reefs here in Kaneohe Bay, which is where Moku'oloi, or the Hawaii Institute of Marine Biology, is located. So while I'm out here at the Hawaii Institute of Marine Biology, I'm working with researchers, part of the University of Hawaii, and in the Coral Reef Ecology Lab. That's where I currently am right now. And our goal is to uncover how corals are calcifying or how they're growing, and how the changes in our oceans are going to be impacting corals and how they're going to be able to continue to grow over time. So we have a lot of work to do, not a lot of time to do it, but we're going to be doing this for the next 3 years. And all of this work is provided and sponsored by the National Science Foundation. So we are very fortunate to be able to come to you through the Texas State Aquarium and give you some insights about coral reefs here in Hawaii. So before I talk a little bit more about the research that we're going to be doing out here, I first want to just talk about a little bit more about what a coral is, because these are amazing, amazing animals. And I'm so fortunate that I get to dedicate my life into understanding more about them and to communicating the interesting things we find about them with you. First, I will say corals are the coolest animal to study because not only are they an animal, they have a microscopic algae that live inside of them. We call those zooxanthellae. And together they live in this unique relationship where they both benefit from each other being there. And we call that a symbiotic relationship. And the coral itself is just a small, a couple millimeters thick live tissue. And then it secretes or grows this calcium carbonate skeleton. So I have an example here of a coral skeleton. Now the coral skeleton itself is white in color. And then we would have a thin tissue covering this coral skeleton. If it was alive, that would be that color that you would see on a coral. And the majority of that coral color that you see is provided by the microscopic algae that live inside of the coral. So not only is a coral an animal, it has a microscopic algae or plant that lives inside of it, and it grows this hard skeleton. Very, very cool. And the unique thing about studying them is not only do you have to understand what's happening with the coral animal, you also need to understand what's happening with the algae that live inside of it. And together you need to know a little bit more about the structure that they're building. What we're going to be talking about for our research that we're doing out here in Hawaii is the importance of this skeleton structure. The corals grow, they secrete this calcium carbonate structure, and this is what supports and builds our coral reefs. So the more a coral grows, the more three-dimensional structure it provides on a reef, and the more homes and services it can provide for the animals that depend on coral reefs. So this is really important that our corals keep growing, they keep sustaining this growth over time, and they're not declining. And that's what we're going to be focusing on. So I mentioned earlier, our primary research question is, how are corals growing and how is that impacted by the changes that are occurring in our ocean? And what I mean by changes in our oceans are getting warmer and our oceans are getting more acidic. And we're really concerned because these changes that are occurring have been shown to decrease the coral growth or coral calcification. And we're going to be looking at that for the next 3 years to help influence some policy and management to help offset the impacts we have on corals. Now, in order to do this, you might be thinking a little bit more, well, how exactly do you measure how much a coral is growing? How do we look at that over time? And we do that in 3 different ways. The first way that we do that is we weigh the coral and we weigh it over time. And then we look at how that changes during that whatever period of time. For us, we're going to be looking at a month growth. We can also use this biological stain so it doesn't hurt the coral at all. We can expose the coral to the stain in the water. The coral will incorporate that into its skeleton, and then we'll see this nice, beautiful pink color. Then we stain the coral, then we can measure how much has grown since we stained it. So you can see the staining is here, and all of this white is new growth. So then we can use our tools, we can measure how much it's grown over that period of time. So that's the second way we measure how corals are growing. And the last way, which I think is the coolest way to measure how corals grow, is we can look at how corals change the chemistry of the water. So if we put this coral inside of a closed beaker and we take a sample of the water, we look at the chemistry of it, and then we take another sample after another hour, we can get an idea of how much the coral has calcified within that time period. And that's because every time a coral calcifies or it grows, it changes the chemistry. And we can look at that change in the chemistry and calculate how much it's grown in a shorter period of time. So for the next 30 days, we're going to be doing all of those measurements. So you can imagine how much work we have to do in such a short period of time. So let me say a little bit more about the corals we're going to be working with. So I'm going to move my camera, so bear with me, to show you the 2 species of corals that we're working with. So this is the first species of coral. This is Montipora capitata, or the common name is the rice coral. And this is a very common coral here in Hawaii. And then the second coral that we're going to be looking at is Passalipora acuta, or it's also called the lace coral. So you can see that they look very similar. They're both branching types of corals, but the biggest difference that we see with the previous work that we've done is that this coral here, the rice coral, seems to not be really impacted by some of the changes it experiences. And then this coral has been impacted, and it's different because they're different species. And we want to investigate that a little bit more. So we're going to be doing that work over the next 30 days and exposing the corals to these different types of chemistries that we're expected to see over the next 20, 30, and 50 years. We've done some work before, and I just want to show you visually what the corals look like. This coral, we stained it again, so all the white is new growth. We stained it and we grew it under ocean acidification, so that's more acidic oceans, over a 10-month period, and there's not much new white growth on this coral. And then, of course, we want to make sure that when we do any types of experiments, we have some control. This is our control coral. So you can see the white stain or the pink stain is down here, and there's a lot more growth that has occurred on this coral. So you can imagine if we have these acidic oceans, there's going to be a big difference in the amount of growth in these corals. And we're going to keep doing this over the next 3 years to get an idea of what we're expected to see for both of these species in the near future. The last thing I want to tell you about, the most important part of this research that we're doing, is we're not only looking at over this 30-day period how corals are changing, we're also looking at how they change throughout the day. So calcification, or the amount of growth, is facilitated by light. So we see higher growth during the day and we see low growth at night. And sometimes the corals are even dissolving. So we want to get an idea of how much dissolving is happening. So we're going to be doing measurements overnight where we stay up for 30 hours straight, and we take measurements every hour to look at that change in the chemistry of the water. And it's really fun. It's very challenging because you're really tired. It's 3 a.m. You just want to go to sleep, but you're committed and you need to understand how the changes at night are impacting the corals. So we're going to be doing that on Tuesday. So if you're interested in learning more about that, make sure you check out our social media sites, which is at the Bahr Lab, and you can learn more, and I'll be posting more of our journey during that 30-hour period as we look at how the corals are impacted over a 24-hour period. And the last thing I want to do before I take any questions and make sure that you're entering your questions into the chat is I just want to show you our experimental setup, the tanks that we use, because that is the coolest thing about working out here is right now I'm sitting on an island and the reef is just right there. You might be able to see it right behind me. And I just want to show you the tanks that we're using and show you the coral reef real quick before I come and sit back down and answer some of your questions. So just make sure that you are you're putting your questions into the chat. And I'm going to get up and walk over here. And I apologize for the maybe the lag my experience. And it might be a little bit louder because I'm right next to where water is running. So these are our experimental tanks. We call them mesocosms. I also like to call them very large hot tubs, but they're not warm right now. Right now, they're completely empty because we're getting ready for our experiment. So we'll make sure they're all clean and ready to go. Each of the tanks will have a different type of chemistry. So you can see we have 12 tanks. We'll make sure to have a control for our experiments to make sure that we have something to compare to. And then right here, right off this ledge is the coral reef. So you can imagine how easy it is to study coral reefs here because the reefs are right here. This is all a coral reef. And the nice thing about working at this facility, it's state-of-the-art, beautiful facility, is that we're able to bring water in right here from the ocean, put it into our tanks, which are over here, and simulate the conditions that a coral experiences right here on the reef, but then change the chemistry of the water so we get the most realistic response possible for these corals. So this is the most realistic way to understand how corals are going to be impacted by change that is occurring in our oceans. Very cool facility. I've been working here for the past 11 years. And I every time I come here, it's just like coming home to my corals and being able to do some of it's just breathtaking. And I'm just going to take you over here so you can take a peek at the corals that we have inside of the inside the tanks right now. You can see we have some air. I'm just going to remove the air so you can see. So inside of this tank, this is our holding tank. We're making sure we have all the corals that we need, and then we're going to randomly put them into the other experimental tanks. And we're also going to be dyeing the corals so we can get an idea of what that skeleton growth looks like. So this is one of the species of corals. This is the lace coral. And then this other tank over here also has the rice coral inside of it. So we have all of those ready to go. They just came from right over there. That's their home. We'll measure their growth over the 30-day period. And then when we're done with them, we'll put them right back onto the reef where they belong. So we're not harming the coral. We're just seeing how they're impacted by the change. So we're going to be doing this for the next 30 days. And I'm now going to pause so I can take some of your questions. I'm going to sit back down so I don't give anyone motion sickness and see what kind of questions that you have. And I'm going to answer a couple of questions and then I have to log off after that and get back to work. But let's see what kind of questions that you have. So I'm going to first start off with, why did I choose to study corals? And I kind of briefly mentioned this when I was talking a little bit earlier about what corals are. If you look more and you have a chance to check out the conservation series, the first one, it talks a little bit more about who I am and where I came from and my background. And one of the things that I really enjoyed about learning and studying marine biology was all the different organisms that are in our oceans that I had never experienced before. And the core question, or the core foundational species that I had no idea existed growing up in Ohio is coral reefs. So when I got to experience them for the first time when I was in Florida, I was just astounded by these tiny organisms that support such a variety of different marine animals. And they're so small, they're just a couple millimeters thick, that live tissue, but they're able to grow and build these huge structures. And some of these structures you can actually see from space, such as the Great Barrier Reef, all built by corals. And that's just amazing to be able to understand and see these tiny animals making such a huge impact in our oceans. So that's the reason why I was really interested in studying corals. The next question I have is, how often do I travel to Hawaii to conduct research? So like I said, I've been here since a little over a decade now, conducting the work. I used to live here. Now I'm an assistant professor at Texas A&M in Corpus Christi. And I have been working and continuing my collaborations with the researchers out here in Hawaii since I've left, which has only been 3 years now, but I come out usually twice a year, mostly during the summer, because I have a break from my teaching at the university. And I come out during the summer and I do a lot of different types of experiments. I bring my students with me so they get to experience coral reefs. And then we do this work together with my collaborators out here. And then I also try to come out during the winter time as well. And it becomes really important to do these experiments, not only during the summer, because the summer is very warm, the water is a little bit warmer, and we want to get an idea of how that warming water impacts corals, but we also need to do it during the winter where the water is a little bit cooler, because we're going to see a change in the growth based on what the temperature is as well. And we want to see that interaction between the warming waters and the acidifying waters and how that might impact the corals in combination. So for the next 3 years, I'm going to be coming out here during the summer and during the winter. So it'll be between June and August, and then also in January, so we can get an idea of what the calcification looks like. And then the last question I want to answer is, how do you reduce your impact on corals and coral reefs? And I think this is the most important question to talk about. When we think about our daily lives, we might feel that we might not live in Hawaii, we might not live in Florida where there are corals, but regardless of where we live, we still have an influence on our coral reefs. You might not be able to see them, but you are still benefiting from them in terms of your medicines and in terms of the fish that you might get at the market. You're still benefiting from them, and they're still providing a lot of livelihoods for people around the world. And although you might not feel like you're connected with them, you are still connected with them, and you are still going to have an impact on them, even though you might feel like you're far away. And like I mentioned, the core question behind the research that we're doing out here is understanding how the changes in our oceans are impacting the coral's ability to grow these beautiful structures that support nearly 25% of all marine life. And the way that we can reduce the changes that are occurring in our oceans is by directly reducing the amount of carbon that we're putting into the atmosphere, because the carbon emissions is causing these changes, the warming that we're seeing in our oceans and the acidification that we're seeing in our oceans. And it might sound like something that's just way too big for you to think about or try to deal with, especially with everything else that's going on in the world right now. But there is small things that we can do in order to reduce our carbon footprint. You may be familiar with from school, reduce, reuse, recycle. That's a really great way to reduce the amount of carbon that you're producing in yourself. Also, you can buy local. So knowing where you're getting your items from, the less amount of travel that they have, the less carbon that's associated with them. You can walk or bike instead of using your car. I know that might be challenging sometimes, but where you can offset, try to offset. And one of the biggest things that I like to recommend is eating lower on the food chain. And this is something that's so simple. You can take part of Meatless Mondays, or you can reduce the amount of red meat that you consume. Just something very small, but it makes such a huge impact. And the reason why I want to just wrap up by talking about the impacts that we have on corals is because that the changes that are occurring in our ocean is happening so fast that the corals can't keep up with it. And these are such amazing ecosystems that we want to keep them around. And if we work together, we can try to reduce the rate of increase in warming, rate of increase in acidification. And hopefully together we can make sure coral reefs are around for our children and our children's children and so on. So together we can make a difference. We just need to work together and be aware of the changes that are occurring. So I want to thank everyone for being live with me today. Thank you again for your patience. I promise we got this now. We know how to do technology. If you have a chance, please check out the Texas State Aquarium Conservation Series to learn more about the research that we're doing. We're going to have more live events for you, so make sure you're signed up for the newsletter so you can learn about when those are happening. And if you want to follow me on my journey while I'm here, make sure you follow our social media page. Again, that's at the Bahr Lab. We're mostly posting on Instagram, so you can see our overnight experiment. You can see how tired we are, and you can ask us questions through that as well. Thank you again for your attention, and I look forward to seeing everyone in the future. Have a great day.